All right, so we're given this PDF f of y here. And the first part of the question asks us to find a value of c that makes f of y a valid PDF. Now, for f of y to be a valid PDF, we require this, that we have the integral over all the values of y for f of y is equal to 1. So for our first step, we're going to need to evaluate this integral here. So we evaluate it. So from minus infinity to infinity, f of y dy is equal to, so the first part, we can look at minus infinity up to 0 is going to be 0. And we're also going to have that from 1 up to infinity, f of y is 0. And that's because our PDF says that anywhere that we don't have y between 0 and 1, it's equal to 0. And so when it is between 0 and 1, we have this function here, c times y squared, 1 minus y all squared. And it seems pretty obvious that this integral and this one are going to end up being 0, so we don't really need to worry about those. Now, we will look at this middle integral. I'm going to start by just taking the constant c out and expanding this bracket here. So I'll end up with y squared minus 2y cubed plus y to the 4 dy. All right, now I can solve this integral. So we'll get c multiplied by, we've got 1 on 3 y cubed minus a half y to the 4 plus 1 on 5 y to the 5, evaluated at 0 and 1. So now we can solve that. When we sub those ones in, we'll get 1 on 3 minus a half plus 1 on 5. And subbing that 0 into the function will just give us all zeros, so we don't need to worry about it. Now, if we add up those fractions correctly, it should give us 1 on 30. So this whole thing here is going to be equal to c over 30. And what we wanted was for this integral to be equal to 1, which is what we said. So therefore, what we require is that c over 30 is equal to 1, which will just give us that c is equal to 30. Part B of this question asks us to find the cumulative probability distribution function, this big F of y. And that CDF is given by this integral from minus infinity up to y of f of u du. Now, we're going to have a look at sort of the few different values of y. So first of all, if y is less than 0, then our f of y here is going to be equal to minus infinity up to y of 0 du. And that's because if y is less than 0, then our little f is going to be 0. And so that is just equal to 0. Now, if we have a look at if y is greater than 1, we will get that f of y, which is equal to minus infinity up to y of f of u du, where we can split that up. So it'll be minus infinity up to 0 of 1, of 0 du, plus 0 up to 1 of 30 u squared 1 minus u all squared du, plus 1 up to y of 0 du. And this integral here will be 0, and this one here will be 0. And from part A, this integral over the PDF from 0 to 1 is equal to 1. So this whole thing here is going to be equal to 1. All right, now we can have a look at the case if y is between 0 and 1. So in this case, we'll get f of y is equal to 0 up to y of 30u squared 1 minus u all squared du. And that will be equal to 30, and now we've got 0 to y. And if we expand those brackets, we'll get u squared minus 2u cubed plus u to the 4 du. And we can solve this very similarly to how we did in part A. So that'll give us a third u cubed plus a half u to the 4 plus 1/5 u to the 5 evaluated at 0 and y. So we can sub in that y, and we will get 1 on 3 y cubed minus a half y to the 4 plus a 5th y to the 5. And that 0 will just give us 0, so we don't need to worry about it. And we can bring that 30 back in to get a bit more of a simplified form. We can factorize out a y cubed, and that will give us a 10 minus 15y plus 6y squared. So to sort of summarize, the whole CDF, sorry, f of y is going to be equal to 0 if y is less than 0. It's equal to y cubed 10 minus 15y plus 6y squared if y is between 0 and 1. And it's going to be equal to 1 if y is greater than 1. Part C asks us to find the probability of y being greater than 0.5. So we want the probability that y is bigger than a half. This is equal to 1 minus the probability that y is less than or equal to a half. And this probability of y less than or equal to a half is exactly the same definition as our CDF. So it's 1 minus our capital F of a half. Now we can use our CDF from before, which give us it is 1 minus, and we will get a half cubed times 10 minus 15 times a half plus 6 times a half squared. And once we evaluate all of this, it will give us a half. Part D asks us to find the expected value of y. So the expected value of y is given by this formula, the integral over all the values of y of y times our PDF f of y dy. And so this will give us from 0 to 1 of 30y cubed 1 minus y all squared dy. Now we can solve the integral. We bring out the 30, and we can expand these brackets here to give us y cubed minus 2y to the 4 plus y to the 5 dy. And solving that integral, we will get 1 on 4 y cubed, y to the 4, sorry, minus 2 on 5 y to the 5 plus 1 on 6 y to the 6 evaluated at 0 and 1. So we can sub in that 1, which will give us a quarter minus 2/5 plus 1/6, and the 0 will give us zeros. And this will simplify to be a half. Now, part E of this question asks us to find the variance of y. So the variance of y is given, can be found using this formula. It's equal to the expectation of y squared minus the expectation of y all squared. So we want to find the expectation of y squared. So that is given by this formula. Expectation of y squared is equal to the integral over all the values of y squared times the PDF of y. And so that will give us from 0 to 1, 30 y to the 4, 1 minus y all squared dy. So just like we were in the last part, we can bring out the 30 and expand this bracket on the inside to give us y to the 4 minus 2y to the 5 plus y to the 6 dy. And we can solve the integral again. We'll get 1 on 5 y to the 5 minus 2 on 6 y to the 6 plus 1 on 7 y to the 7, evaluated at 0 and 1. Now subbing in 1 again, we will get 30 times a fifth minus a third plus 1 on 7. And evaluating all of this will give us 2 on 7. Now we need to find the variance. So the variance of y is the expectation of y squared, which we found to be 2 on 7, minus the expectation of y all squared. From part D, we found that the expectation of y is a half, and so we can square that. Now evaluating this will give us 1 on 28 as our variance.